Hi everyone, welcome. So in this video we're going to look at preparing you for Performance Task Part 1, which is on quadratics. And in your grade 10 academic course, quadratics fell into 3 units. Unit 3 on polynomials and factoring introduced the idea of factoring quadratics, okay, and expanding them. And in Unit 4 we looked at quadratic functions, which focused mainly on what does the quadratic look like, how does it graph, and then doing max-min questions, okay, application type questions, where we completed the square. In Unit 5, we continued to work with quadratics, and we learned how to solve a quadratic. And to solve a quadratic, you use factoring to do that, or you can use the quadratic formula. And of course, in Unit 5, we had applications that we were doing this solving for, okay? So go into the section on our website called Performance Task and Exam. So it loads up. In class, you received a stapled handout that included Performance Task Part 1 Quadratics Review with Answers, and Performance Task Part 2 Linear Systems, Analytic Geometry, and Trig Review with Answers. That package was a series of questions that we've chosen to kind of prepare you the best we think for the performance tasks. Okay, so let's open up Performance Task Part 1 Quadratic Review with Answers just to make sure we have the right one. So it's loading up here. Okay, so here's the handout. We're going to look at some of these examples in this video lesson coming up, and you're highly encouraged to complete the entire handout and get help with any areas that you're unsure of. Back to the website under Performance Task, there's several other handouts that essentially are summaries of what we did in each unit. So in Unit 3 on polynomials and factoring, I'm just going to click to open that. So there we go. And I'd like you to download this on your own and take the time to read through all this. And you're going to see all the key topics from this unit, Unit 3 here on polynomials and factoring. Things like expanding, FOIL, difference of squares, product of a sum and difference, factoring techniques like simple trinomials, complex trinomials, perfect square trinomials. We developed all those skills in Unit 3. Okay? Back to this website, and if you open up the factoring flowchart, I would print this off or find your old factoring flowchart, and you need to kind of have it to your left as you work through questions. It's basically a flowchart that reminds you which steps to take when factoring, and you want to get to a point in your mathematics where you're able to do this by memory. Okay, factoring is quite big in grade 10, 11, and 12 for high school, and is a skill you'll carry on with you even post-secondary. So find this and make sure you use it the way we used it during the units on factoring. Okay, in Unit 4, we looked at the quadratic, which is an x squared type equation. And we've studied its properties, okay? And here was the review we used. So make sure you have a look at this, all right? And this will help prepare you with Unit 4. If I had to summarize Unit 4, it's essentially looking at what the quadratic looks like to graph, looking at its vertex form, looking at its standard form. We learned how to find the max-min, which was an optimization technique. And we realized completing the square was a tool we used to do that, and interpreting the vertex. And we had specific types of word problems we did. We did a lot of ones where we were like launching projectiles, like this firework being launched, or a golf ball being hit. They all involved finding a max, okay? We had other questions sometimes that involved having a min. Whether you're finding a max or min, you always need to complete the square and interpret a vertex, okay? The other types of word problems we did involved like rectangular fields where we were maximizing area, or maybe two numbers and we had to find the minimum product. And then we did like revenue questions where we wanted to maximize revenue. All of them were using quadratics and usually in vertex form where we were interpreting that, or we could be given a quadratic in standard form and have to convert it to vertex form by completing the square and then interpret that info. Also in this unit, you were given the graph of a quadratic and you were asked to find the equation, to discuss properties of the quadratic like the stretch factor, the compression, the how much it's been translated to the left or right or up or down. You had A values, H values, K values. So that's what the content of this unit was. It was definitely one of the core units to this course. I'm just going to close this, okay? And this section here, full solutions, is the written out full solutions to the document I was just looking at. So if you want to have a look at this, check your notes if you printed it off or print it off at the moment. You can go through all these solutions to help you study. Okay. Finally, in Unit 5, we continued with quadratics, and after having found the maximum with quadratics in Unit 4, or found the minimum with the quadratic in Unit 4, in Unit 5 we said, well, let's just solve a quadratic. And when you solve a quadratic, there's two ways to do that. Okay? And the first way we said, well, when you factor, you're actually setting yourself up so you can solve a quadratic. So that's why factoring came back, and all these different techniques to factor became important again. The other way to solve a quadratic is to use the quadratic formula, which is something we looked at in Unit 5 as well. Okay, so you definitely want to look at that. I'm going to reopen this document again, and you'll see here, obviously the first sheet that came up was the factoring flowchart, but this is a 9-page document, and for some reason this is there twice. Okay, you want to probably read through and have a look at what solving is. And all the examples here were the same ones we did when we reviewed for the unit test in Unit 5. Okay, so go through this, read it like it's review. It refreshes the core techniques or applications or different like formulas like the quadratic formula, and gets you ready and gets your mind back on to this type of math. All right. And then over here, there were applications in Unit 5, and the key applications we did in Unit 5 when solving quadratics had to do with numbers, areas, and borders. Okay, so this opens, if you'll remember, we had solved worksheet number 4. So go back in Unit 5, even you can use my website for Unit 5, go find worksheet 4. There were several word problems on number, area, and border, and we'd solve them. These are partial solutions. Okay, and you had to submit your full solutions at that time in class. And I mean, most of you had done them like flawlessly because you were given about 4 or 5 days to do that. Really make sure you were refining and like working these skills out. So back to the main part of the website that looks at performance task and exam preparation. I'm now going to go into performance task part 1, quadratic review with answers. Okay, so the document's loaded. Here's the plan. I'm not going to cover these questions exactly. Let's say I'm doing number 1. I'm going to cover a similar example by changing the equation or maybe changing a word or two, and then I'll solve it. After that, you'll have a completed example, and you can try solving number 1 and obtaining the right answer. And I'll do this for a select number of questions in this review handout, and the idea is to prepare you and show you the right skills, methods, form, okay, and common mistakes to avoid so you're successful with performance task part 1. Okay, let's look at question 1. So take a minute to read it, and I'm going to solve it, but I'm going to use a different equation. Okay, in number 1, the equation's changed, and let's let's express this as a completed square, and then we can state the coordinates of the vertex and the max min value of the function. So first thing is we complete the square. Okay, to do that, you're only concerned with the first 2 terms. And what you do with those first 2 terms is you common factor the coefficients in front of x squared out. Okay? And I say first 2 terms, I mean the x squared term and the x term. So put brackets around that, and I only common factor exactly what's in front of the x squared out. This is completing the square, and that's step 1. Okay? So minus 3, and then how does minus 3 get back into minus 3x squared? Well, best thing to do is what's minus 3x squared, divide by minus 3, and that would be x squared. Okay? Or another way to look at it, minus 3 times what gives minus 3x squared? Well, minus 3 has to multiply x squared. Okay? So let's look at it that way to determine this term. Minus 3 times what gives 6x? And it's minus 3 times minus 2x. Okay? You could have also done 6x divided by minus 3 would leave me with minus 2x. There's always those 2 ways. Okay? And then plus 2 hangs out at the end, and you have to include them. And then you have to look at this term here, and consider his coefficient of -2. And as a side, you take that coefficient of -2, you divide it by 2, and you square it. Okay? And the answer to that, -2 divided by 2 is -1. -1 squared, 1. Okay? And the point of that is you're now going to add 1 and subtract 1. Well, adding 1 and subtracting 1 is like adding 0, so it doesn't change the equation. All right, where do we do that? So -3, open your bracket, x squared minus 2x. Now we're going to add 1, subtract 1, which is like adding nothing. And close the bracket and continue by adding the +2 that's on the end. Okay, here's why we do that. In here, right here, this is a perfect square trinomial, a PST. We can factor that as a perfect square trinomial, okay? And I'll do that shortly, but first, I need to remove this term from inside the brackets. Before I'm allowed to do that, though, this term's multiplied by -3. So -3 has to come, multiply -1. -3 times -1 is 3. And then he comes outside of the bracket. And we show that on the next line, okay? So I'm going to actually do this. -3 x squared minus 2x plus 1. And remember, the -3 times -1 has now come out. It's +3. And there's still the +2 there. And we've removed this term that's not part of the PST out of the brackets. Okay? What's left is to do this. This is still a PST. And you have to use your perfect square trinomial factoring technique to factor that as a PST. Alright, here's how that works. First off, -3, he just gets carried down. Time to do the PST. A PST works like this. You square root the first term here. Okay, there's brackets. So you square root the first term here and write it down in front. You square root the last term and you write it down here. And then whatever sign you have here, I'm in the way here. Whatever sign you have right here, we have a negative, gets carried down to here. All right, and then you square. All right, don't forget 3 plus 2, that's 5. All right, so how do you check if your PST is correct? You can go backwards. This is what we would call a binomial squared. See, a binomial squared becomes a trinomial here, and to undo that trinomial, you can PST back to binomial squared. Here's the check. Take this first term, x, multiply it by itself. X times x, it gives x squared. Okay, next check. X times -1 times 2. Well, that gives -2x. And then -1 times -1 gives +1. So you know you're okay. You've finished completing the square, and you should recognize this as a form. It's vertex form. So now you can answer all the questions that are within question 1 on the review handout. All right. First off, this sign here is negative, so we know that it opens down. The quadratic would open down when graphed, and that means it's a max. Okay? The other thing we know is that's the a value, so this is stretched by 3, though that wasn't asked for in the question. What was asked for in the question is what is the vertex, or what is, where does the max occur, which happens to happen at a vertex. And the way you would read the vertex is there's your h value, and 5 is your k value. And for this guy, it would be 1, 5. Okay? We talked about how the x in here, whatever's working with the x, lies to you. So that's why it's +1. And then outside here is the k value, and it doesn't lie to you. It's just actually 5. Now, when they say state the maximum min value of the function, well, the maximum min value of the function is 5. Okay? When they ask for that, they want like the y value. So the y value of the vertex. So in this case, it's 5. So the max value in this case, because it is a max, is, well, it'll be y equals 5. All right, make sure you can see that. And that's what they asked for in question 1. Let's look at doing a question similar to number 2 here, so sketching a graph. So I'm going to create a graph question with a different equation, and we're going to sketch it as per question 2 and answer all the questions. Okay, let's try it with this equation. So you should recognize this as vertex form, because as soon as you look at that equation, you know that the vertex is, well, this is positive, so it's a minimum. And that means it'll open like this. Okay? You know the vertex can be given away from these values. So your vertex, which is a minimum, is, remember, he lies to you, so it's positive 1, 6. And that is the minimum. Okay? So the next thing you want to do is identify your step pattern. Now the basic step pattern for a quadratic, the basic step pattern for any quadratic of form y equals x squared. Okay, so that's the most basic quadratic. His step pattern is 1, 3, 5. But if we want to generalize it, okay, to a quadratic with ax squared plus bx plus c, which if it were in standard form, or even if you wanted to do a x minus h squared, okay, plus k, the basic step pattern, if you're in vertex form, is a times 1, 3, 5. All right, so our a value, okay, is right here. We have an a of 2. So that 2 like scales the step pattern, okay, and as follows. So the step pattern for this specific quadratic equation, what you do is you distribute that 2, and the step pattern becomes 2, 6, 10. Okay? And now let's go over how we take the step pattern, the vertex, and the fact that this is a minimum to sketch this graph. Alright, so I've prepared a graph here and transferred some of the key info, so I know it's a min. It's got a min at 1, 6, and that the step pattern is 2, 6, 10. Okay, so here's what you do. Start by identifying your minimum, where x is 1 and y is 6. So count over x1, go up 1, 2, 3, 4, 5, 6, and there's your min. Okay, so there's your min. Let's label it 1, 6. Step pattern wants you to do this. Starting from your vertex, go over 1, up 2. Then, once you get there, so over 1, up 1, 2, you need to go over another 1, so 1 squared to the right, and up 6 this time. So over 1, up 1, 2, 3, 4, 5, 6. Okay? Now, along the center of your the quadratic that you're graphing is an axis of symmetry. It's like a mirror line that divides the quadratic in 2 symmetric halves. And we tend to add it in as a faint dashed line so we can see. Okay? So there it is, a little faint. The nice thing is once you've done one side of the step pattern, the other side of the step pattern is mirror image along the axis of symmetry. So if this point's here, just go the other side of that axis of symmetry, and you can put your other point down. You can even check that. You can go over 1, up 1, 2, which satisfies that. And then from here, over 1, up 1, 2, 3, 4, 5, 6. Okay, and we'd be over here, which again holds the symmetry because it's from here it's over 2, and from here it's over 2. There's always that nice symmetry. Okay, so I'm just going to bold these. Now, when you sketch your quadratics, These are curves, so make sure they have the curve-like look. I'm actually going to draw this here in orange. And I usually do 1/2. Alright, and then put an arrow. Now I could go up to 10, but I'm running out of room on my graph. So at least get a couple steps up and then put arrows to show that it continues. And over here I would continue it down this way, and add the arrow, and I've sketched the graph, and I've shown the coordinates of the vertex. Okay, what about the y-intercept? This question wants us to do that, and it looks like we don't even need to calculate it. We can see it from the graph. So the y-intercept for this graph is actually right here. Okay, so it doesn't say to calculate it. May as well just list it and read that off the graph. So x value is 0, and I got to go 1, 2, 3, 4, 5, 6, 7, 8. 0, 8. Great. What about the domain and range? Well, remember this. All quadratics, okay, unless you imply a restriction, which we haven't done in grade 10, but all quadratics have a domain, okay, a domain where x is an element of all real numbers. Always, okay? Then for the range, that relates to y values. And the range of the y values, well, you'll never go any lower than that y value there. In fact, they always go up from there. So y is an element of all real numbers such that the y values are all greater than or equal to that y value there, which is 6. Okay? And back to domain, XCR, the reason it's all real numbers, because this goes up forever and would keep widening out over time as you move towards infinity, it would eventually spread out across the whole x-axis of this Cartesian plane, and it would basically hit all real possible numbers. Okay? All quadratics have domain XCR, and all quadratics range will always have some restriction depending if it's a max or a min. Number 3 says, find the equation of the following parabola. Let's do one similar together. So if we look at the parabola I've given here, we have to take a look and see which key points have been given to us. Okay? So I see that I've been given a vertex, and I recognize that as a maximum. Okay? And that's like being given the hk. Okay, and for this question, h and k would be -2 and 3. And then you have to see what else you were given. Were you given any of the roots? So the roots would occur here. We also call roots x-intercepts, or solutions, or zeros, and we don't have them. If you don't have the roots, solutions, or zeros, they all mean the same thing, then you know you will not use this form, which is considered a form we use in Unit 5, and it's called factored form. Okay? We don't have root r and root s, so this here will not work for us. Let's look at what we have here. We've been given this point here, and that to me, that's a y-intercept. Well, there's no y-intercept form. Alright, so what are we going to do? Well, let's go back to the vertex here. Oh wait, let's use vertex form. Okay, so I'm just showing you this type of thinking you go through. Had I given you the roots, you would use this. But I gave you a vertex here, so you're going to need vertex form. And the vertex form, in general, for a quadratic is the following. You have to memorize these things. Okay, so y is ax, y times ax minus h squared plus k. And let's see if we've been given enough info to solve for all the variables that we need to in the standard form, in the vertex form of a quadratic. Okay? What we're looking to have, we want to know a, h, and k, and then we leave y and x. They're the variables in the equation alone. And great, we have h and k, and we're going to have to find a somehow. But to find a, we're going to need an x and a y. Well, that's where this y-intercept comes in handy. We're going to use this x value and that y value. And we're going to substitute 0 in for x, -1 in for y, -2 in for h, and 3 here in for k, and we'll be able to solve for a. So here we go. Okay, one at a time. Y, let's look it up. It's minus 1. I'm going to use brackets to contain that. A is unknown. Open my bracket. What's my x value? I'm using the y-intercept's xy value. So his x value is 0. Take away. My h value is, okay, careful here, minus 2. And then I need to square that. And then I add k. And k is positive 3. Okay? Now you notice the only unknown is a, which is actually the stretch factor. It tells you how much the graph of a quadratic is stretched. Okay, to solve this, the goal is to find out what a is. So you have to kind of undo everything that's happening with the quadratic here and a. First thing is this 3 is going to go over to the other side. So we only have, the goal is to only have numbers on that side. Full numbers on that side, and then we'll leave only a on this side at the end, okay? When he comes over, it becomes the following. You have a minus 1 there, so the minus 1 stays there, and you now have to subtract the 3. Change sides, it changes its sign, okay? A is still here. Let's work out the bracket now. 0 plus 2, well, that's 2, so when here's 2, you square it, you get 4. Well, that just became this, okay? Let's follow through. Next line, look left to right. Okay, I have to take minus 1 and take 3 away from that, and that's minus 4. And this is really just 4a's, but I know I have to undo 4 times a by dividing by 4, and I have to do it on the other side to keep things fair. And a, well, let's do this. Minus 4 divided by 4 is minus 1, so the a value is minus 1, okay? As I look at my answer for a being minus 1, I like that because the a value in the quadratic tells me, well, its sign tells me whether this opens up or down. And when it's negative, it's supposed to open down and give a maximum, so I'm happy to see that. Okay? You have to now summarize and give the equation because you have everything known. So the equation would be the following. Y equals, now the a value is minus 1. You just put a minus sign. You don't have to put 1. Okay? X. Now we have to put in the h value, and our h value for this equation will never change, and it's up here, it's minus 2. So remember that lies to us. When we put it in here, it's plus 2 squared, okay, and then the k value is just exactly as it is, it's 3. And there is the equation for that graph. We have to do one of these on our unit test, and there's even one of these on our tips. This is from unit 5. Number 4, the larger of two numbers is 8 more than the smaller. Okay, you can finish reading it. What I'm going to change is some of the conditions in this question, so let's have a look. Okay, so I've changed this so the larger of two numbers is 6 more than the smaller, and find the numbers if their product is a minimum. Alright, so if you've got two numbers, well, you're going to need some let statements with two numbers that are unknown as x and y. Okay, and then to find the numbers if their product is a minimum, you're going to need to find their product, and let's call that p. So you do need let statements, so I'm just going to write them out. Alright, so here's my let statements. Let x be the smaller number, y is our large number, and p is going to be our product. And when you read these questions, you got to be careful and look for keywords that tell you whether you're either optimizing or solving. And we optimized in unit 4. And the keywords to look for optimization were words like the minimum. When you see words like minimum or maximum or max value or find optimize something, you know that whenever you see that, you're going to need to complete the square. All right? As opposed to seeing things like solve, or the absence of words like maximize, minimum. If you see the words like solve, okay, that means you're going to be factoring. If you're not factoring, you're using the quadratic formula to solve. Okay, so here we're going to need to complete the square, but only after we create an equation that relates this situation. Okay, so let's do that. So if in this question, the larger of the two numbers is 6 more than the smaller, who's the larger one? Well, y is the larger one. And if I want to get him to equal out to what x is, who's the smaller one, well, x needs some help. He's smaller than y, right? So x needs to catch up. And by how much? Well, it looks like it's by 6 more. So if I add 6 to my smaller number, he now equals the same size as my larger number. So there's your first equation, okay? The second equation is find the numbers if their product is a minimum. Their product, so the product of my two numbers would be x, y, and the product we used was p, okay? So, and we want to make their product a minimum, so we're going to be minimizing with this equation. So we're going to have to complete the square on this equation, but only after we do one important step. That's equation 1, that's equation 2. You need to sub 1 in 2. Anywhere you see y in equation 2 here, you'll replace it with x plus 6. So there's the y, and now I need to replace. So let's do that, all right? So p equals x, and now instead of writing the y, I substitute x plus 6. Okay? Now we notice we'll have an equation with one independent variable and one dependent variable, which you need before completing the square. All right? You need to distribute here. So x times x times 6. Let's work that out. P equals x squared plus 6x. All right. So now we're at a point where we're ready to go after the minimum by converting this equation, what's going to be vertex form, using completing the square. So in step 3, I'm going to complete the square for this equation, which by the way is in standard form, and completing the square is going to put it in vertex form and allow me to identify the minimum. So here we go. I'm just going to rewrite. Okay, when completing the square, you only care about the first two terms, and well, this equation only has two terms. And then you want to common factor anything that's out before the x squared. Well, here there's really nothing to common factor because there's just a 1 there. So this is already done. Okay, I mean, there's really no point in writing this line. It has no bearing and no effect. Write it anyways, all right? So, next step in completing the square is you take a look at the coefficient before the x. Okay, not x squared, but before x, who's degree 1. And you take that number, you do your little side calculation. 6, he gets divided by 2, and then squared. That's 3. 3 squared is 9. All right, that 9 will be added and subtracted with the goal of setting up a perfect square trinomial after. Okay, I'm going to drop this 1. He has no effect. So back to this. X squared plus 6x. Now I'm going to add 9, subtract 9, and close the bracket. Okay? That basically adds 0. And it's a technique that allows me to take a look at these three terms now and recognize that these are a perfect square trinomial. A perfect square trinomial, PST. And when you have a PST, the form you use to solve, the form you use to factor goes like this, all right? So this entire underlined orange part will become the following. You need brackets, okay? Square root of that, so square root of x squared is x, you write it out front. The square root of 9 is 3. You drop this sign, so it's positive, you drop it down here, and you put a squared out there. And you can check to see if that's right by doing this. Okay, because this is now a binomial squared. Watch, I'll get back this answer by doing the following. X times x, x squared. And you do x times 3 times 2, x times 3 times 2 is 6x. All right, and then you do the last term here, 3 times 3, 9. And you've confirmed it's fine. Don't forget about this last minus 9 hanging out. All right? There he is. There is what we want. That is in vertex form. Okay, and if you're looking at this, you see here that it's positive. So this means it's a minimum. Okay, and the vertex, okay, which is h comma k, occurs where? Well, remember, h is always here and it lies to you. So at -3, and then the k value is -9. All right, and then normally like you have x, y, but this is not an equation in form x, y. This is an equation in form x generates a p. Okay, so this is your x value, and this is your product, your p. So that's how we interpret that vertex. All right, let's reread the question and make sure we answer it correctly. So the question said to find the numbers if their product is a minimum, and the numbers are x and y. So from the vertex, which is a minimum, we now have the x value. Okay, so we're interpreting that x must equal -3. And it's simple calculation to find our y from equation 1, y was equal to x plus 6. So we're going to substitute this x and figure out what our y is. So x is -3. We're adding 6 to that. And y equals 3. Okay, so as a fifth and final step, numbers, you have to summarize. So the numbers, well, looks like they're -3 and 3. All right. Let's try some factoring questions similar to number 5 here. I want you to keep something in mind. Whenever you factor, you're solving, okay? And if you can't factor, if you're asked to factor and you just can't do it, remember, you can use the quadratic formula, and the quadratic formula will solve, will essentially do what factoring does, and give the same answers or answer, okay? So it is at least a backup to solve if you have to happen to not be able to factor a specific question. Okay, at least for quadratics here. This is specifically for quadratics. So the quadratic formula obviously only works for quadratics. All right, so to solve this question, you're not allowed to guess and check. You need to do it by factoring. So you're going to want to grab your factoring flowchart. This is a 3-term, and the coefficient in front of x squared here is 1. So grab your factoring flowchart. You've got a factoring question. There's no common factor if you go back and check that. There's 3 terms. And then you're asked, is the coefficient of x squared 1? And we did say yes, it is 1. And let's check if it's a perfect square trinomial. So if it's a perfect square trinomial, you would be able to take his square root and his square root, and they would have to be perfect. Unfortunately, the square root of 42 gives decimals, so it is not a perfect square trinomial. So it is not a perfect square trinomial, therefore you end up with a simple trinomial. So if this is a simple trinomial, you have to look for the following. This term here is your sum, and there's your product. And we drew these little tables. You need 2 numbers, okay, with the following. So the product being 42, and the sum being -13, you want to try and find 2 numbers who when multiplied give 42, and when you add them up give -13. And we said that you have to start thinking about, well, numbers that multiplied give 42. So 1 and 42. They'll never add anywhere near 13. Okay, 2 and 21. And you keep going. 2 and 21 will not get anywhere near 13, whether you add them up. And then you check 3, okay? And then you would say, like, well, 3 goes into 42 14 times. So 3 times 14 is 42, but 3 and 14 will never get 13. You keep doing that exercise, and you're going to realize that 6 and 7 give 42. All right, but 6 plus 7 equals 13, and that is not what we want. So you get smart about this, and you go with minus 6 and minus 7. That gives a product of 42. Minus 6, take away minus 7. Gotta try to word that. Minus 6 plus minus 7 will end up being minus 13, and those are your numbers. And the format to answer these questions, okay, was always this when it came to a simple trinomial. So you would put x here at the front, and then you'd put the two numbers you found at the back end of the parentheses. So minus 6, minus 7, okay? And then I'm just carrying this equal side down. All right, and then you look at that, and these are what we call the zeros or the roots, okay? And then you simply solve them. You say, well, what would this have to be to make this go to 0? X would have to equal 6. What would this have to be? X would have to equal 7. And now you've solved using factoring. Those are your two answers. Those are actually your two roots, your solutions. They're also the x-intercepts of this quadratic equation. Let's look at solving 5b by factoring. So if I look at 5b, it's 4x squared plus 28x plus 40. As soon as I see that, I think of my flowchart. Okay, so let's go look at that. I've got a factoring question. Is there a common factor? Well, 4x squared plus 28x plus 40. X is not common in all these, but what about 4? Does 4 go into all these since he's the lowest number? And you should realize that yes, 4 does go into all these, and it would look like this. Okay, so I've rewritten it here. And if I common factor out 4, I'll have the following. Okay, 4 is out front, and then it's 4x squared, because that gives 4x squared. 4 times 7x gives 28x, and 4 times 10 gives 40. All right, so now that I've common factored, what do you do now? Well, now that you've got the 4 up front, he won't have any effect anymore. So you now look at this new quadratic, okay, who's a trinomial, and you ask yourself, is this factorable anymore? Well, it won't be, no, because remember your flowchart wants you to ask that question each time. It's a factoring question. Is there a common factor? Well, there's not going to be another one. Okay, so now you're down, how many terms are there? And there's, well, let's take a look. There's 3 terms, and then it'll say on your chart it's 3 terms. So is the coefficient in front of x squared 1? Yes, it is. And then we can check if it's a perfect square, and if not, we do the simple trinomial technique. So let's check if this is a perfect square. Can I square root x squared? Yes, and I get x, and it's perfect. Can I square root 10? Well, I can, but unfortunately 10 square root is not perfect. It gives a decimal. So you're stuck with simple trinomial. And if you were practicing this enough, you can avoid using this table, and you can do that work in your head. You need 2 numbers whose product gives, 10, and whose sum gives 7. All right? So those 2 numbers are the following. So what are 2 numbers whose product give 10 and who, when added, give 7? Well, 1 times 10 will never add to 7. 2 times 5, that adds to 7. So there's your winning numbers. 2 times 5 gives 10, and 2 plus 5 gives 7. All right, so here's how that looks. You don't do anything with the 4, and then you just write out your answers with the usual brackets. So when you do a simple trinomial, x goes out front. Okay, and the winning numbers were 2 and 5. Okay, and that's how you put that in. Now you actually have to do the solving. Okay, so to solve this, 4 has no effect. No matter what you do, 4 won't change to anything to make this equation go to 0. What has an effect is in here. You could put a minus 2 here. If you put a minus 2 here, minus 2 plus 2, all this goes to 0. 4 multiplies 0, whatever this is multiplies 0, and it would satisfy this equation. In other words, it would solve it, which means one of the solutions is x equals minus 2. And by the same logic, if you put minus 5 in here, you will end up solving this equation, and that, my friends, is your 2 solutions, your 2 roots, your 2 x-intercepts, okay, for this quadratic, which solves it. All right, solve by factoring for 5c. So I've written this out here. Okay, the first step when factoring, check your flowchart. Ideally, you need to know this by heart. I'm going to refer to it here to remind you guys. So factoring question, yes. Is there a common factor? Is anything common across these three terms? They don't have any common numbers. Okay, so you have a 6, a -1, and a -2. They don't all share an x, so there's no common factors. There's three terms. Okay, so then it'll say how many terms are there? 3. Is the coefficient in front of x squared 1? No. You've got yourself a complex trinomial. Unless, of course, it's perfect squares. So let's check if we can square root this first x squared term and get a perfect number. No. If I square root 6, it is not perfect. So you're done with that. Then you're left with decomposition. And here's how decomposition worked, okay? So what you need to do is you actually take this 6 and you multiply them by the last value here, the -2. And that creates your product. So over in your product sum table, your product is 6 times -2, so your product is -12. Okay? And then the sum is that value right there. Okay, and the sum there with the minus sign would mean it's -1. So we need two numbers that when multiplied, okay, give -12. And when you add those numbers, they add to -1. And I know that 3 times -4 will give -12. And then 3 plus -4 will give -1. So those are your two numbers. And then when you actually do the decomposition part, so what happens is this middle term, it gets replaced by two terms. And it's the two winning numbers. Okay, so I'm going to write this in. You do the following. 6x squared stays. You break this down into these two winning numbers. So one of them is 3, and it's x. And then the other one's -4x. And you notice that 3x take away 4x gives -1x. So you've broken him down. You've decomposed him into two terms. Okay, and then keep the -2. All right, what's the next step's called is known as grouping. And the best way to do that is just group these first two terms, and then you'll group these two terms. Okay? This first group, on its own, you kind of like forget this for a second. Just look at this first group and common factor it. So look for common factors. Okay, let's do the numbers first. 6 and 3, what's common? Well, 3 is common. All right. Do they have x's? Yes. So he brings x to the power 1. He brings x 2. So the highest you can go with is 3x. You open the leftover brackets. And now you follow through on common factoring. 3x times what gives 6x squared? 2x. 3x times what gives 3x? 1. Okay? Now you're ready to strictly focus on common factoring this group. And let's see what we have. So we've got a -4 and a -2. Okay. Looks like I'm going to go with -2 as a common factor because there's no x in both of them. So -2 times what gives -4x. If you don't like thinking that way, you can think the other way. -4x divide by -2. What's -4x divided by -2? 2x. Okay, and then you can just check it. -2x. Excuse me, -2 times 2x does give -4x. All right, and then -2 times what gives -2? +1. And you're really, 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 really happy, okay, when you see that this and this, so this binomial here and this binomial here match. All right, all you need to now do is write that out front. 2x plus 1. So these are common. Like this is one giant term, and this is another giant term. And each of those terms has this binomial in common. So you write him up front. And what's left over goes into a new bracket. 3x, okay, -2. And I'm just noticing a silly error that I guess I even tend to make, as you can see here. This was supposed to be solved. So you don't need these equal signs here. So I can't erase because I'm using pen. It should equal 0, equal 0, equal 0. You're carrying this down, okay? Now you look at these, And these are two parts to this equation that could make this go to 0. So you have to solve two little equations. So what's 2x plus 1? We set it to 0, or 3x minus 2 equals 0. Because if we can get this to go to 0, get all this to equal 0, find the x value that does that, well then no matter what happens over here, this being 0 times that, it still makes the equation 0. And the same goes true for the other side. We can find out what makes this 0. Well, once this becomes an x value that's known that makes this 0, we'll put it in here. Whatever happens over here, this 0 times that will solve the equation. So let's solve these little equations. You'd have to send that over. 2x would equal minus 1 divided by 2, and x is minus a half. There's one solution. Okay, solve this one, send that number over. 3x would equal 2. Divide out that 3 to isolate the x, and x would be 2/3. And there are your two solutions to this particular quadratic. Number 6 says to solve using the quadratic formula. So let's look at a similar example. So we have the following: minus 4x squared plus 1 equals 3x, and we want to use the quadratic formula. Well, first thing you're going to have to do is find that you put this in the right form. You need ax squared plus bx plus c. And this is mixed up right now. Okay, so you're going to need to send 3x over. And we're going to end up doing this. So you want the x squared term first, minus 4x squared. Then you want the x term. And for us, it's minus 3x because you change his sign when he comes over. Then you want 1, and this would equal 0. Okay? And then what you realize is you can solve this with the quadratic formula. Okay? And there it is. You should have to be identify who's A, who's B, who's C. So there's your A, B, and C. So A is minus 4, B is minus 3, and C is 1. They go into the quadratic formula. Okay? And the plus minus means you can get anywhere from, well, no real roots if you end up with a negative in the square root. Or the plus minus could end up giving you up to 2 answers there. Okay? So you'll do all this math. Remember, you have to show your 2 answers. X equals, and then there's could be that second option. Okay? So make sure you practice how to do that. Let's try Jim Short's question here and his flower bed. And then after that, you could try a question like number 3 here with the rectangular lawn. Okay? That's surrounded by a walk. A cement walk. So let's do Jim Short's. Okay, so I've redrawn basically the diagram that affects this question. Alright, and here's how you would proceed. Okay, so Jim's yard's in here. And it tells you in the question that it's 12 by 15. I didn't quite draw it to scale. So this is 12 meters, and this is 15 meters. This should be longer, but it's not the scale diagram, just representative. Okay, so the area of the yard, so A subscript yard, it's rectangular, so length times width, 12 times 15 is 180 meters squared. Okay, that takes care of his yard. And then it says Jim wants to put a flower bed. So the flower bed's this area here. Okay, all throughout here. And he wants that flower bed on the outside of the yard. How wide should the bed be if the area of the area of the bed is a quarter of the total area of the yard? So this area here, so the area of the bed, well, it's a quarter this area. So again, it's not to scale. And a quarter would mean it's 180, and it's divided by 4. It's been quartered. So the area of the bed is 180 divided by 4. And you're going to end up with 45 meters squared. Okay, So now you have, what you have now is you have the total area here. And here's why we're going to need this. Because the question says, how wide should the bed be? And when you see a question like this, you should immediately recognize it as a border question. Okay, so the borders we've done have always been, these corners here are unknown, and we call it x. Okay, and it's continuous. There's sort of a symmetry. All these lengths are the same. So we have to say, we'll do our let statements. Let x be the width of the bed, and we're going to let A be the areas, and then we're like specifying what areas. We have the A of the yard and the area of the bed, and we're going to have one more right now, okay? The important thing to do now is the following. You need the total area, okay? So the first step's like diagram, you get your little area calculations, you're going to need to do your let statements. Now, let's talk about the total area. So the area total. Okay, so the total area would be the yard with the bed. So it's 180 plus 45. And when you add those two up, you get 225 meters squared. Here's why you do that. Whenever you have 225 meters squared, you get the entire area. Now, if you can assign this total length and this total width with these numbers and the variables, you're going to be able to make an equation that relates to area total. And what I mean by that is this. So the total length here, well, what would it be? There's this x plus 12 plus x. So really there's 2x plus 12. Okay? And the same kind of logic applies for width. We've got x plus 15, because this is 15, so this is 15. So x plus 15 plus another x, and then the overall width is 2x. I'm just going to make some room, plus 15. Okay? So I wrote it a little squished in there, but you can still see it's 2x plus 15. So now you know that the entire area has dimensions 2x plus 12 and 2x plus 15, and you can make an equation with that, okay? So I'm going to do the following. The area total, I'm actually going to write it here, 225, okay? And its length, 2x plus 12, times his width, 2x plus 15. Alright, so these are becoming binomials that are going to end up being FOILed, and you're going to end up with a quadratic equation that you're going to be able to solve. Alright, so next step is to FOIL. Alright, FOIL is our multiplication technique, and just take your time, and here we go. This stays here. 2x times 2x, 4x squared. 2x times 15, 30x. 12 times 2x, 24x. And 12 times 15, we said was 180. Okay, there's some like terms. And there's also the 225 to deal with, who can fall into the like terms. Okay, so we're going to send him over. You'll have nothing left here. You have 4x squared. 30x plus 24x is 54x. And 180 is going to work with negative 225, because he comes over as negative 225. So 180 take away 225 will give you minus 45. And there's the quadratic you're going to work with. You need to solve this quadratic so we can just uncover what the x value is. Okay? And when you come to this point, you have to make a decision. You have to decide whether you can factor this, or the other way to solve is to use the quadratic formula. Since the Jim Shorts question doesn't say whether to use solving by factoring or solving by quadratic formula, it's up to you to decide. So let's look at trying factoring. Okay, if I look at these three terms and I need to factor them, there's no common factoring available. Okay, you can't factor 4 out of 45. It's not going to happen. So that there's no common factoring. Then you're looking at three terms where this is not 1. Okay, so when that happens, you're looking at, is this a perfect square? Well, you can square root 4x squared, you'd get 2x, but you cannot square root minus 45. So then you're looking at decomposition. And if I look at decomposition on this, it looks a little daunting, okay? So when I see that, I'm probably going to err on using the quadratic formula. The quadratic formula will allow me to solve this, okay? And my a value is right here. There's my b value. And here's my c value. So let's use the quadratic formula. Okay, so let's substitute. Okay, b is 54 plus or minus. Okay, put the square root after. So b squared, that's 54 squared minus 4. And what's my a value? 4. C is minus 45. Okay, now I'm going to put my square root. I have to divide all that by 2 times my a value. So 2 times 4. Okay, and then I work this out in three parts. Just check that. All this in here and then the bottom. So this is minus 54. Okay, so 54 squared. I'm going to put that in my calculator. 54 squared. And then watch your signs here. Watch what happens. Minus 4 times 4 times minus 45. So these two negatives will make for a positive contribution there. So this is 4 times 4 times 45, and I want the positive result out of that. So 4 times 4 times 45 is 720. So I'm doing 54 squared plus 720. 54 squared plus 720, and I get square root of 3636. Okay, and then I divide that by 8. Okay, so next step. You know, advance this up so we can see it. Okay, and now it's minus 54 plus or minus whatever the square root of 3636 is, and take a few decimals, 60.299. 60.299 over 8. Now, the quadratic formula creates two answers because the plus makes one and the minus makes the other. So one answer is x equals minus 54 plus 60.299 over 8. And then the other option is x equals minus 54 minus 60.299 over 8. Okay? And those are calculations you should put directly in your calculator, and you get the following. So there are my two answers. X is 0.787. Okay, and these are in yards. And then x equals, minus 14.287. I can't have a negative yard. I reject that. You can't have a negative answer. Yards must be positive. So therefore, you know you're going with 0.787 yards. Okay. And the last step to finish this off, how wide should the bed be if the area of the bed must be a quarter of the total area of the yard? End this with a sentence. I'm going to save some time here. So you'd have to say it's approximately 0.8 yards in width. Okay, so let's look at the remaining questions. So we've just finished Jim Short's. On the next side of this sheet, question 1 here, just going to zoom here. It says to solve by factoring. And the thing is, we just did questions like that. So number 1 here reminds me of number 5. So you want to refer to those examples that I did for number 5. Solve using the formula. That means the quadratic formula. So it reminds me of having done number 6 here. You'll need to set up the quadratic formula. And as I said earlier, number 3 with the lawn, reminds me of Jim Shorts and his lawn. Okay, and then quadratic functions sketch the graph. On the graph, show the coordinates of the x and y-intercepts and the vertex. Reminds me of this question we did over here at the start, number 2. Okay, so what else? You want to enclose a rectangular area along the side of a river. If you have 600 meters of fence, find the dimensions that will close a maximum area. Remember, the side of the river is that's on the river doesn't need any fencing. Okay, one of the key things I want to point out with this question is, as you read it, well, you recognize that you are dealing with a rectangular shape, and another key word is maximum area. When you see that word, maximum, or if it had said minimum or optimize, as soon as you see the word maximum, you need to think, after I make my equation, I will need to complete the square. Completing the square will give you vertex form, and then from vertex form, you can read off the maximum. Okay, the maximum is the vertex. All right, so I'd like you to try that one on your own. All right, and that's going to conclude taking up this sheet. All right, so this is kind of the core questions from the quadratics units. And the other things I can recommend you do would be to look over your units 3, 4, and 5, specifically 4 and 5. Look over your quests and your tests, okay, and even your tips that we did in those units. And just try and identify the questions that come up quite a bit. Reminding you too that the performance tasks are going to be, they're going to feel like tests where you're doing mostly application questions. All right, so bring your questions to class. We can work on improving your skills if you have questions or just going over and refining things, and we'll see you soon.